Okay, so question 2. We have the probability distribution of the discrete random variable x is given by probability x is equal to x is k times 5 minus x for x equals 1, 2, 3 and 4, or probability x is equal to x is 0 otherwise. So to start this question off, I would draw myself a little table, because in part A we want to show that k is equal to 0.1, so we're actually going to want the probability distribution for this discrete random variable. So we're going to put in 1, 2, 3 and 4. Okay, so what we end up with here, let's put in x equals 1 into our function. So I get 5 take away 1 is 4, and then 4 times k is simply 4k. Please make sure you write it as 4k and not k4. It's simply bad algebra otherwise. So I'm going to put 2 into my function. 5 take away 2 is 3, so times the k gives me 3k. And you probably see a little pattern emerging here. 5 take away 3 gives me 2, times the k, so we get 2k. Can you see that the k's are just decreasing? Now this isn't in every probability distribution, it just so happens it's in this one. So probably the next one's going to be 1k, but let's just double check anyway. 5 take away 4 is 1, so as I said, it's going to be 1k, and you can just simply write that as k. Now, what we have to remember when we answer this question is that we want to show that the probability, we want to show that the sum of the probability that x equals to x will come to 1. So it's a full mathematical notation definition there for actually the sum of probabilities. So basically what we want to show is when we add all of these probabilities together, it equals to 1, and we're going to use that to solve the problem. So we're going to have 4k plus 3k plus 2k plus k is equal to 1. So just coming across the line, adding up the k's, 4 plus 3 plus 2 plus 1 is 10k, which equals 1. I'm then going to divide both sides by 10, and so that gives me k equals 0.1, exactly as defined here. Please remember, when it says show, it doesn't mean put 0.1 into this and show that it works out. It means that it actually wants you to solve it, but it's giving you this probability here to work out the rest of the questions afterwards in case you can't answer this first question. Now, before I go on to solve any other problems, it's probably a good idea just to then write my probabilities, 4k is 0.4, into this table for use in the rest of the question. You can answer it in terms of k if you want to, and then substitute the k value back in, but I like to actually see the probabilities in the table, so I'm just going to put the probabilities up there. Okay, so part B says find the mean and variance of x. Well, the mean is of course the expectation, so as you've seen before, just make sure, use your notation to find it. You're going to find the expectation and then show your full working out. So that's x times your probability, so x times 0.4, and then we're going to do that for each one of the x values, and we're going to sum them up. So you just need to show that you are multiplying each of these values, each of the x values, by their probability in a summation in order to get your working mark. And then once you've done that, you can just use your calculator in one step to find what that expectation actually is. So when we work out that expectation, we should get an answer of 2. Okay, so then variance of x is the expectation of x squared, take away expectation of x all squared, so I need to find out the expectation of x squared as well. Remember that this can be done very simply by just copying what you've done for the expectation of x, except you're going to square all your discrete random variable values. So that's all the x values, 1, 2, 3 and 4. You still need to show it in this sum, There's no shortcut for this. You just have to work through it. Again, show all the working out, show the summation calculation for your working mark, and then once it's actually written out, you can use your calculator, and once you type this into your calculator carefully and evaluate it, you get an answer of 5. Now, once you've worked out your expectation of x squared and your expectation of x, you can calculate your variance of x. So your variance of x is given by, remember, it's the expectation of x squared minus the expectation squared of x. So we're going to take the expectation of x squared, which is 5, and I'm going to take away the expectation of x, which is 2 squared. So 5 take away 2 squared gives me an answer of 1. And there we have the expectation of x and the variance of x. Okay, now part C, although it's labelled wrong in the question, part C says given that x1 and x2 are independent observations of x, determine the value of probability x1 equals x2 plus 1. So what we're thinking about here is we really need to understand what this means here, that x1 is equal to x2 plus 1. Essentially what we're saying is find the probability that your first observation is 1 more than your second observation. So we're just literally saying probability, start off with the smallest possible x2 value. The smallest possible x2 value is 1, so 1 more than that is 2. So what we're saying is probability that the first observation is equal to 2 and our second observation is equal to 1. And it's as straightforward as that. I just want to consider when was the first observation 1 more than the second observation. The way to work out this probability, they're independent events as you're told in the question. So we're going to do the probability of 2, which is 0.3, times the probability of 1, which is 0.4, and we get an answer of 0.12. Okay, now is that the only way I can observe a value that's 1 higher in the first observation than in the second observation? No, it isn't. So I can also observe that x1 is equal to 3 and x2 is equal to 2. So I get 0.2 times by 0.3. Okay, again, because they're independent events, multiply these two together, I get 0.06. Is that the only way I can observe the first value being 1 larger than the second value? No, it isn't. There's one more way that I can do it, because the maximum value that I could possibly observe is 4, and so that would mean that my second observation would have to be 3. And so we then get probability of 4 times the probability of 3, which comes out as 0.02. Now, we've now found out all the possible ways that I could observe a first observation 1 more than the second observation. These are all mutually exclusive events. They can't happen at the same time. So if I want to know the probability that the first observation is equal to 1 more than the second observation, then all I have to do is it can be any one of these 3 observations which are mutually exclusive. So I'm just going to sum up those probabilities. Remember that this part is a little bit like using a tree diagram, because we've got the AND rule where we've multiplied the probabilities of 2 events together, a combination of 2 events to get a probability of that outcome, and then the OR rule where, because these are mutually exclusive events, I sum up their probabilities in order to find out my total probability. So when I add these all together, we get an answer of 0.2. And that is that question finished. Okay. Now, let's have a look at how you're awarded marks in this question. So, in part A, 2 marks. The first mark is given for a correct table. The second mark is then given for correct working leading, so that's this whole line here, showing the 4K, this whole bit here from 4K onwards to this, so inside this curly bracket, that is given 1 mark. So a full and clear explanation demonstrating how you've got to this value k equals 0.1. Okay. In part B, 1 mark is given for the line of working, this summation, and 1 mark is given for the answer in each of these. So let's squeeze in a little one there. That is for this working here. Okay, and then you've got 1 mark for this answer of 2. It's exactly the same for the expectation of x squared. You've got 1 mark for the summation line, showing how you would work out the expectation of x squared, and then 1 mark for an accurate answer of 5. Your final mark in part B is then given for the variance of x, and it's just given 1 mark for actually calculating the variance of x is equal to 1. And that gives you your total of 5 marks for part B. Okay, in part C, you're given marks for each of these lines, so showing that you've understood that it's the first observation is 1 more than the second observation. So 1 mark for calculating probability x. The first observation is 2, second observation is 1. 1 mark for calculating the correct probability for first observation being 3, the second observation being 2. And 1 mark for correctly calculating the first observation would be 4, and the second observation would be 3. You then get 1 mark for demonstrating that is the summation of these 3 probabilities that would give you the total probability that of the first observation being 1 higher than the second observation, and then 1 mark given finally for that answer of 0.2 actually to the question. This leads to a total of 12 marks. Okay, I hope that all made sense.